Hi, everyone. Welcome to the Data Scientist Podcast. I'm very happy to have here with us today Stefan and Elijah from DAGWorks. And we're going to have a very interesting conversation around data engineering, pipelines, data science, LLMs, AI, and a lot of other stuff. Hi, guys. Welcome to the show.
Hi, Stylianos. Thanks for having me.
Hey, thanks for having us.
Would you like maybe to introduce yourselves and say a few words about DAGWorks and what it is that you guys are doing? What's the problem you're solving?
Sure. So my name's Stefan. I'm the CEO of DAGWorks. And at DAGWorks, we're trying to build the one way for you to express data, machine learning, and LLM pipelines. And then with a one-line code change, get kind of lineage, catalog, and observability without you having to add in extra tools. The problem, in a broad sense, is we're trying to enable teams to be more human capital efficient with how they kind of build pipelines. So can we enable the data scientists to be able to do more? And if there is a handoff model, make that more efficient, or if there isn't, make that data scientist be able to do more without having to have have the software engineering background to be able to do things themselves.
Hey.
That's me, DAGWorks, and Elijah.
Yeah, hey, I'm Elijah, the CTO. I come from a background of building tools for data scientists. And Stefan nailed it on the head. But just to add to that, we are open core. So we're based around an open source library called Hamilton, and it's a way of expressing these data flows, right? So you express your data flows in Hamilton, and then you can plug into the DAGWorks framework, all to make your ML, LLM, and AI pipelines more human capital efficient.
Yeah. You might hear us using the word data flow. It's effectively the same word as pipeline or workflow. There's ETL. Many different synonyms.
Anyways,
but suffice to say, it's all the same.
That's fine. Perfect. So what is Hamilton really? Like, what's the origin story?
Yeah, so Hamilton Elijah and I created it at Stitch Fix. There was a team at Stitch Fix. So Stitch Fix, for those who don't know, had over 100 data scientists, and it was a personal styling service. They effectively had data science teams helping with different aspects of the business. One of the teams we were working with was forecasting team that helped kind of forecast demand, that then helped forecast inventory and a few other things in the business. They were one of the oldest teams at Stitch Fix, but they, you could say, their macro pipeline. So in terms of getting a new forecast out so the business could make decisions on, was they were kind of struggling to iterate and kind of push stuff out. So the pipeline was up, but really the code that was within the pipelines was the struggle for them. And so on a work from home Wednesday, Elijah and I prototyped two different versions. But the idea was, how can we enable that team to think less about their code and more about writing the things that matter to them, which is building features, connecting it with the data set, and then building better forecasts. So
it started off with feature engineering for time series forecasts. By the end of the time that we were at Stitch Fix, I think they were managing 4,000 or 5,000 features with Hamilton, and we realized that it was very broadly applicable. So not only was it useful for sort of this case of feature engineering with time series forecasts, but could also be applied to sort of any sort of standard machine learning pipeline, LLM workflows, a bunch of other sort of AI applications as well.
If you can model it as a flowchart or a directed acyclic graph, you can model it in Hamilton pretty well.
Okay, that's fascinating. And what sets you apart from other tools in this area, like Airflow?
Yeah, so Hamilton focuses on the micro, right? So what I mean, so micro versus macro. So I think of Airflow as a macro system. Airflow is really trying to if you have an end-to-end pipeline, like one task could be getting the data, another could be creating a training set, another could be fitting a model, and those tasks are very computational kind of, they're bounded by computation, right? Whereas with Hamilton, we're focusing, the problem was the code within the task was the issue, and so that's where we started. But from if you focus on the micro, you add in more micro, you can model the macro, and so with Hamilton, it has this interesting ability for you to model something logically end to end, but without having to say, well, this part of the directed acyclic graph or this part of the flowchart, right, is one task, this is another task. You get to make a decision later. And so really, so the differentiator is that aspect between, say, Airflow, but it's also, it's just a library doesn't contain state and runs anywhere that Python runs. Elijah?
So to be clear, you can run, Hamilton is most often used along with a macro orchestration framework that you might know, such as Airflow, Kubeflow, Metaflow, Dagster, Prefect, whatever. And you'll run Hamilton on top of that, where like one of these macro orchestration frameworks won't tell you exactly what's happening inside your code, won't sort of help you document it and understand it and share it with other data scientists. But Hamilton will help sort of bridge that gap, right? So it works naturally with those as a level on top.
Okay, very interesting. So how much can this scale? Like, what are some of the, let's say, bigger case studies you have?
Yeah, I mean, so scale is in terms of, so one dimension is like, code and people, right? And so at Stitch Fix, as Elijah was kind of saying, that team, by the end of our tenure at Stitch Fix was, managing over 4,000 feature transforms, right? In a single code base in a small team. So usually when you add code to a code base, it gets slower, right? But this team could continue cranking and adding to the code base and continue to kind of scale it. So from that perspective, like Hamilton, I think scale is much better and helps code bases and people and teams and structure scale much better, just because it's an opinionated way to write Python code that make sure your code is always testable, documentation friendly, you get lineage as code, right? And so it's very amenable to help scale a team. And we also have the compute side. Elijah, you want to take?
Yeah, so in terms of the compute side, Hamilton is going to work along with a bunch of Python tools already that are really good at helping you scale. So Hamilton works with PySpark. We just have a new company using PySpark on Hamilton that scales up to, I think, hundreds of billions of data points. It works along with polars, works along with pandas. So whatever Python can do, whatever sort of way you already can scale, Hamilton can latch onto that and help you organize it.
Yeah. So for example, there's hooks for Dask and for Ray, which are also common ways to kind of scale Python code. In which case, Hamilton, part of the the reason why we built it was to help abstract a little bit of the where things run from what should happen, right? And so the data scientists care about what should happen, but platform teams care about how it should run. And so trying to provide a nice interface there to make that pluggable and enable you to like accumulate less technical debt as kind of your code grows.
I see. And what are you currently seeing in the space of LLMs? Do you feel that, I don't know, this is going to change things? Also, like with respect to features, like you mentioned demand forecasting or something like that. I guess, forecasting structured data is very different to large language models. We've seen some LLM focused services in the last year or so. Actually, today I was looking at the service by Amazon. How is this affecting what you guys are doing?
Yeah, I mean, so there's a hunger for new tools, so we kind of see that. If you think of LLM workflows, they can be pretty well modeled as a DAG, and so LangChain, one of the incumbents kind of tools that people use in the area, is the common criticism, and it's bad for production or hard to take to production, and does a poor job of modeling a day cyclic graph. Hamilton, was purposely designed for that, and is also works well for production. So actually seeing interest, for people to use Hamilton as the one tool, as I kind of mentioned in the beginning, across data, machine learning, and LLM pipelines. So you bring in one tool, you don't have to learn something else, and you can kind of describe your workflows that way. In terms of myself as a classically trained NLP person, I see LLMs really being able to replace most classic NLP use cases. So if you want to extract entities, you want to summarize text, you want to do query expansion, LLMs, I see at least anyone who's doing classic NLP stuff is basically you have to be using some LLM somewhere. Otherwise, we still see in terms of there are people still trying to figure out, for example, evaluation. So how do you evaluate it? But otherwise, I don't, Elijah, if you have thoughts, but like from what we've seen, most of the problems seem pretty similar or analogous to traditional machine learning or ML ops kind of problems. So if you hear the term LLM ops, we don't actually view it as that different. Obviously, the tools and maybe the techniques that you're using for certain things might be different, but in terms of like the shape of the problem and what you need to think about to get to production and maintain it well, we don't think there's too much new there, other than just having to learn how do you evaluate something? Okay, how do you ensure that if you're depending on OpenAI, you can depend on their model or detect changes quickly, etc. Yeah.
So, yeah, to build on what Stefan said, I'm a big believer that LLMs are just sort of an evolution of your standard MLOps, which is why you see all these companies quickly moving over to now offer LLM solutions, right? You're calling out to a generative or predictive model. It's an external API. In a company that's big enough, you'll already be doing this in 18 different ways. So at Stitch Fix, you had model services all over the place, and then to serve a customer, you just start paying these. Replace one of those with OpenAI, and now you've got a service mesh serving LLMs, and you're dealing with a lot of the same problems: unstable APIs, costly APIs, difficult to evaluate predictions, et cetera. So I think it's a natural evolution, and I think Hamilton is really nicely positioned to sort of bridge that gap, to take it from your ML pipeline that might do your regressions, your sort of very typical stuff. You want to replace one piece with a call out to an LLM. That's a very easy thing to do in Hamilton.
Yeah, I mean the other side in terms of, I guess, what we're seeing is there's a lot of people who are still trying to, I guess, figure out how to get to production. So there's a lot of people who are just playing around, and so this is where I think there's some people who are taking a wait and see approach. The other is in terms of data. People I see more so than they did with machine learning is really trying to ensure that they can have a domain over their data, and so in which case solutions and other things, like we're actually seeing more interest in kind of on-prem kind of solutions, which mean from a vendor perspective, SaaS was the easiest way to get kind of started, but seeing more interest for people to really want to protect their data, and so in which case this is where part of the evolution we kind of see it, just like in traditional machine learning, people ended up training their own models, right? Just because they had the data that, this can be, you can think of fine tuning as kind of, retraining a model from a warm start, right? So we kind of see the pendulum swinging a little bit back into people being interested in, like, how do I fine tune? How do I reduce my costs? How do I, make better use of GPUs, which was, all problems that you kind of generally had with machine learning MLOps kind of side of things when you're really trying to get machine learning to production and run it efficiently and effectively.
You mentioned MLOps a few times. What are some of the current trends you're seeing in terms of MLOps? How much do you think the space has matured? I mean, it's only a buzzword that came about in the last few years. Before that, I mean, I come from an era where, being a data scientist meant you'd also deploy your own stuff. Now we're just hearing about MLOps as a different thing. What's your take on that? What do you see happening in this space? My personal feeling is that things are probably becoming a bit easier, but it would be interesting to hear from you, and also what happens at scale, if we're talking about really, really massive organizations.
Yeah, I think MLOps is if you're familiar, there's a term called DevOps, which was around having a developer be able to do processes and kind of ship to production themselves. Because back in the day, that was also a handoff process where the developer would build something and then the operations person would kind of operationalize it. You see kind of MLOps kind of just being more of a, thinking more in a more disciplined fashion. So at Stitch Fix, for example, the data scientists were in charge of kind of deploying stuff and owning it end to end, right? So just thinking of what are the operations and perspectives and hooks and principles that you should be thinking about to ensure that if something gets to production, there aren't bad models. How do you prevent them from getting there? If there's a problem, how do you reduce the time to resolution to kind of understand what's going on? So you could say, to your point, I think MLOps is just a name for that process, right? And so if you've been doing it for years, it's probably nothing too new to you. But if you don't come from a software engineering background, I think that's really where we're seeing trying to imbue those kind of best practices to ensure that how do you qualify a model for production? What are the kind of guardrails you need? Do you have kind of some sort of A/B testing sides that you can kind of actually measure the impact of your models, right? So it's really, I think, just a bit of more of a philosophical framing and kind of a framework of how you should approach getting something to production that involves data and code, as opposed to traditional software, which is just code.
I want to agree, but I also want to push a little bit back on that it's more mature. I think in a way MLOps have become more mature. There have been more sort of solutions that work well for people. On the other hand, I think if you talk to a VC or a really optimistic developer in 2019, they'd say, by 2023, we'd have the equivalent of AWS for ML. You just have one standard way to deploy a model, or a few different ways, like the cloud, that would be a totally solved problem. And if you look at it, companies are still sort of building their own custom model deployment solutions. I think because the problem space is just so varied, right? When you have the data, when you have the code, anything could potentially go wrong. There's a lot you have to think about. And I've kind of come around to a way of thinking that you end up building it off of a lot of sort of little pieces that you have to string together. So I think those little pieces are getting more mature. We might eventually move towards a solution, but I think this is still just as unsolved a problem as it ever was.
Like for me, the thing that's really mature is like if you want off-the-shelf infrastructure to run things, like there's a lot more options there, and it's pretty easy. But in terms of the operational process of like the software development lifecycle, the model development lifecycle, right? That's where I think you have to build tooling yourself to stitch together different point solutions. So be it observability, feature store, model registry, deployment, data catalog. So we definitely see point solutions being more mature and kind of the infrastructure side. But in terms of the process of how you stitch everything together, how do you kind of make a cohesive platform, that's still kind of maturing, and that's part of what we're trying to tackle, is to try to make that simpler and easier to stitch together a bunch of things.
So something that's very concrete in the age of LLMs is the problem of if you wanted to do inference on a GPU. This was something that I don't think many people did at all 5 years ago. I mean, I remember I was trying to push it at Stitch Fix when we had one thing and everybody laughed me out of the room because they're like, oh, that's too operationally complicated. Now you see companies, I know Pinterest got this to production, and this is sort of a more standard offering. It's all becoming sort of buried behind cloud compute and abstraction layers that make it a lot easier to do that. I think that's one of those infrastructure ways which has become much easier to handle MLOps.
Perfect. Okay, that's very interesting, because I'm obviously a data scientist myself, so it's interesting to share views with others in that area. I guess one last question before we go is around lineage, which is one of the things you mentioned on your website. I don't think it's a concept that's discussed as much, and I just wanted to hear a few words, mostly for our audience, about.
Yeah. I mean, so I actually realized I didn't answer your scale question. So, but this lineage question dovetails with that. So, one of the things you kind of see as an organization or as your machine learning kind of LLM, whatever you're doing kind of matures, people want to start to build off of each other and start to kind of, if you think of, you start small, but then you kind of keep continuing adding bits and pieces to either the front or to the end of something, right? In which case, you then get, at Stitch Fix, we had teams who were building off of other teams' models, right? And so part of then the change management process, or like how do you ensure that what's happening in production, you can debug easily. If you have kind of clear insight or lineage in between, where did data come from? How was it transformed to like where did it end up? If you have that, then it's much easier and faster when something goes wrong to like root cause. Figure out what's going on. Similarly, it's also if you're trying to discover what is available and you want to trust something as an internal kind of IC or something, having lineage and the ability to go, given this data set, okay, this looks good. But then how do I know what data set or what is the code that produced it, so I can gain confidence that like this particular column in this table is actually what I think it means, right? And so this is where we see I guess with Hamilton, part of the idea is you write Python functions, and those functions encode lineage. And so with normal software engineering practices, you have a very lightweight way to kind of have full provenance on like how something was kind of created, as long as you're tracking and storing things in Git. And so we see lineage as one of these tools to help scale a team and an organization to be able to kind of really understand, not only debug things, but then if you have more enterprise concerns, such as governance or understanding like, hey, where's birth date used? Because I need to audit that we, delete things for GDPR because it's PII, right? You need to kind of have that introspection. And so with all the, the privacy needs and like regulations coming out, like actually understanding, what data you have and where it goes is kind of important from many different angles.
So to build off what Stefan said, I think one of the things that slows down a data organization the most is if I change this data set, who do I impact? And I've seen this like cause projects that should have taken a few weeks take a few months. I think we're hoping to be able to solve that both in terms of individual data sets and pipelines, and even across pipelines. In the DAGWorks product, we're building out ways to sort of like connect multiple pipelines together to really understand how your data flows from one table to another. So it's a big value that we got.
Yeah, I see. I guess this is more useful when you're dealing with bigger teams, right?
I mean, so it depends. It's like it's a cumulative. So it really depends partly on the complexity and how many transforms. But then, like for yourself, it's kind of like if like this is where most people. So individuals build models, but teams have to own them, right? So if you're the individual who owned the pipeline, you're probably like, no, oh, this connects to this, right? It's all in your head. Maybe you've done a good job documenting, but this is where if you can kind of help automate or provide that, then A, you don't have to remember yourself, but then B, when you leave or someone else needs to come and take over your code, there's a great breadcrumb trail to kind of help someone get wrapped up and kind of started. So there's definitely, I think you get more value the bigger the team is. I definitely think that's a little bit of true, but that's kind of because of the communication overhead and standardizing that just makes that that much easier. But you still get value from a single person kind of using it. It's just that it really then partly depends on how much code you write and how complex things are.
So you 6 months ago form a team, right? There's communication boundaries, and we've seen individuals take on Hamilton so they can have this lineage in their code. So when they put it down, it somehow breaks and they have to pick it up on a whim. They can easily figure out what's going on. So I think that's why lineage is good for the individual, and then it scales up to the team, and then it scales up to sort of multiple teams.
Okay, makes sense. So guys, where can someone learn more about you? And if I'm not mistaken, like you said, it's open source, so you're saying, and you can really use it. What's like your website and your GitHub repository?
Yeah, so the GitHub repo, so if you search for Hamilton and GitHub and DAGWorks, we should be the top result there. So I think we're almost at 1,000 stars on this fork of the repository. If you want to try out Hamilton in your browser, we have tryhamilton.dev, which is using PyDide, so you don't need to download anything, and it gives you a brief, like 5 to 10 minute kind of walkthrough in terms of, just this, what is Hamilton and how would you think about it? In terms of our website, you can DAGWorks. You can go to dagworks.io, DAGWORKS.io. And then we have a free tier, so you can sign up, get a free 2-week trial to kind of see what we're building. No credit card or commitment necessary. But otherwise, we also have a Slack community that we're kind of growing around Hamilton as well. So that has over 200 people. And so it's not a small project. It's been out. We're building a community. So we invite anyone and everyone to come check it out and give us a try.
Yeah, we're looking for users, contributors, people with ideas, all welcome.
Perfect. Well, thank you guys. It's been a pleasure. Very valuable insights, and I'm sure our audience appreciated these insights as well, especially the ones that are working in the data space.
Yep. Awesome. Thanks for having us, Stylianos. This was fun.
Yeah, really appreciate it.
Yeah, thank you guys, and thanks everyone for staying here with us today. Make sure to go to thedatascientist.com for more content around data science, AI, and Web3. Thank you.